All right, today we're going to talk about switching from radical form to exponential form. So what you should notice here is that whatever your denominator is right here becomes your root over here, okay? So denominator becomes your root. Same here, your root becomes your denominator, okay? That's how you go from a radical to exponential form. And I want to point out to you also that on number 2 and 3, notice that we're doing fifth root and sixth root. That's a square root. We did square roots in the past. Now we're doing fifth root and sixth root. I want to tell you right now, a square root is not a fifth root, is not a sixth root. So the 6 matters, the 5 matters, not having anything there, so a square root matters. So let's get started. What goes into 108? Well, I know 2 goes in 54 times. Then I know that I could bring down my 2, and 54 splits into 9 times 6. Okay, so then from there, bring down my 2. This is 3 and 3, and that's 3 and 2. Bring down my square root. Now, we don't ever write it here, but a square root does have a little index of 2 there. All right, we just don't write it because math people don't like to write, I guess, and we just assume you know it's there. So for every 2, 1 comes out. So I've got 2 3s, and I also have these 2 2s right there. So 2 comes out and a 3 comes out. And then the 3 has to stay in the square root that has no 1 there. So 6 root 3 would be your answer here. Keep in mind that this index right here is going to tell you how many you need for it to come out. So let's look at 243. I know 3 goes in there 81 times. I know this is 9 times 9. Remember, if I'm going too fast, you can always pause it. You can also, I always suggest that people watch the video through the first time writing no notes and then go through a second time and write notes. So I broke up everything, and this is what I have, and it is a fifth root. Okay, so for every 5, 1 comes out. So this tells you for every 5, 1 comes out. All right, that's what it's saying. For every 5, 1 comes out. Well, there are 5 3s, so 3 comes out, and there's nothing left inside. So straight up, 3 is your answer. On number 3, now I'm going to write this the long way. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. So I wrote this the long way, and now you want sets of 6. All right, so for every 6, 1 comes out. So I do have 6 x's, but I don't even have 6 y's. So the only thing that's going to come out here is an x. And then what stays inside is x times x, so x squared. And all of these y's would be y to the 5th. Okay? There is a simpler way, though, because imagine if it said x to the 80th. Are you kidding me right now? There's no way you would sit there and write 80 x's. So here's the quick way. 6 goes into 8 how many times? Once. With how many left over? 2. Does 6 even go into 5? No. So it just stays inside like that. All right? So on this next part, the shortcut, how many times the index divides into the exponent, you write that as the exponent on the outside, the remainder stays as an exponent on the inside. So looking at this, 3 goes into 6 how many times? Twice, with how many left over? None. So I'm not writing any x's left inside. And notice that I am writing my 3 on my root. You have to write that or it's going to be wrong. 3 goes into 3 how many times? Once. With how many left over? None. So nothing goes inside. 3 goes into 30 how many times? 10 times. With how many left over? None. So nothing goes inside. So straight up, there's nothing left inside there. This is your answer. We're going to do the same thing over here. Don't be freaked out. There's a 5. You're going to treat it the exact same way. So 4 goes into 6 1 time with 2 left over. 4 goes into 7 1 time with 3 left over, your remainder. 4 goes into 5 1 time with 1 left over. So let's clean that up, especially this 5 squared. So this is 5xy, 4th root, 25x cubed y. Boom. Over here, 6 goes into 60, 10 times, with a none left over, which is why I'm not writing any m's inside. 6 goes into 17, 2 times, with 5 left over. Done with that. All right, so that's how you simplify radicals. So what's going to happen is on the back, we're going to put everything together. So what we've done the last couple of days combined with today. So looking at number 7, it says simplify, leave your answer in simplified radical form. All right, so you want to go all the way. So this is negative. We're going to move it up to the top, and make it positive. And we know that here we will add the exponents. 6/5 plus 2/5 is 8/5. Again, I go faster than I do in class here. So you can always pause it and you can rewind it and you can rewatch it. You do what you need to do to get it done, okay? Now, we need to change this to a radical, which we learned today. Remember, or actually we learned earlier. Root here, exponent here. And then we do that same thing. 5 goes into 8, one time, with 3 left over. Done. Over here we have these two multiplying, so we know we should be adding the exponents. And if you use a calculator and you add this would be 24 plus 5. This is 29 20ths when you use a calculator. Change it to radical form. Remember, the denominator becomes the root. And then ask yourself, 20 goes into 29 how many times? Once, with 9 left over. Done. Scooching on down. These two are negative, so you're going to move them to the bottom and make them positive. So that's going to be positive, that's going to be positive. We know that if they're multiplying like this, you just add their exponents. So x to the 9/5. Then you want to change 9/5 to a radical. Remember, the denominator becomes the root. And then 5 goes into 9 one time, so 1, and then it goes in there one time with 4 left over. And that's your answer. Here we're going to start by distributing, which we learned earlier. So we're going to have x to the 7 times 1/3. Let me erase that little scribble there. And then we've got y to the 1 times 1/3. And when we multiply those, that's x to the 7/3, y to the 1/3. Then we're going to switch these into a radical. So this is cube root x to the 7th. And here this is cube root y to the 1st. I like to put them underneath the same root if they have the same root. That's just me. Some teachers don't. I do. So I do this. 3 goes into 7 twice with 1 left over. And here 3 doesn't even go into 1. So it stays inside. So that is your final answer. On this one here, we have a 1 here and a 1 here, so you're going to distribute. So 6 to the half and 25 to the half. Again, if they have the same root, I'm going to write them underneath the same one. But first, let's find out what this looks like. Remember, that goes there, that goes there, that goes there, and that goes there. And they have the same root. Now, I will say, I noticed right away, what's the square root of 25? It's 5. So I would probably do that and be done with the problem. On number 12, multiply your exponents. So a to the negative 12 over 7. We have a negative exponent, and we know we have to move that to the bottom and make it positive. And then from there, you switch that to a root. And then from there, 7 goes into 12 one time with how many left over? 5. And that's your answer. So there you go. Like I said, I would watch it the first time, and then I would rewind and rewatch afterward.